Okay, what's going on in this problem? What's happening? What's happening in this problem? Is there a teacher involved? What is the person involved in this problem called? What is this person called, Tyler? A scientist. Okay, what's the scientist doing?
Has two beakers that contain different amounts of liquid.
Okay, and what are they doing?
She adds 10 milliliters of liquid.
She adds 10 millimeters of liquid. Did you girls catch that? This scientist is a female. Did you know the scientists don't have to be males? Yeah, awesome. Okay, so she adds 10 millimeters of liquid to each beaker. So there's a picture there of beaker A. How much does beaker A start with? It has 50 millimeters of liquid in it. How about beaker B?
20.
It has 20 millimeters. They give that information right here. Starting amount for beaker A, starting amount for beaker B. Now, we just talked about the definition for absolute change, and the first question is, what is the absolute change for each beaker? Anybody think they know? Danny? Okay, so the absolute change is what number? What did she add? 10 millimeters. So the absolute change is what it's going to change by. She's going to add 10 millimeters to each beaker, so that is the absolute change for each beaker. 10 millimeters more is going into them. Now we're going to find the relative change, and relative change is different than absolute change because we are now, what we're doing is we're determining when she adds 10 millimeters to each of these, how does that affect the amount that was in there? What is that change relative to how much was in there to start with, okay? So that should be different for each of these. So let's find relative change for each beaker and compare them. Beaker A, we're going to use our model up there that says, what's going upstairs in the first ratio? What it changes by, right? How much does it change by? 10. Okay, so it's going to change by 10 millimeters, mm. What's the starting amount for beaker A? 50. That goes downstairs. And we are figuring out the percent of change. That's what we're looking for. The relative change is percent of change. So that's where we're going to put our x, and that is going to be a percent after we find it. And what do we put downstairs? 100. Okay. Okay, now we look to see if this is friendly for horizontal or vertical strategy. So let's do this. We would have to get from 10 to x. So we're going to go from 50 to 100. So instead of doing cross products, Levi, what we do is we figure out what do you have to multiply or divide by. Okay? So what do we have to do, Danny? Multiply by 2. So if we multiply 50 times 2, we get 100. So then up here, if we take 10 times 2, we should get our x. So 10 times 2 equals x. So what's 10 times 2, class?
20.
20. And this is 20 what? Percent. We just found the percent of change, okay? So 20% is the relative change for beaker A, the bigger one, the one that started more. So it changes the amount of liquid in there by 20%. Okay, let's look at beaker B. See if you can set up the proportion all by yourself here. What would the proportion look like for this one? What do we do? Hey, Cheyenne? Okay. Yeah, how do you guys feel about that? Think that should work for finding percent of change for this one? 10 millimeters, how much it changes by. Over 20 millimeters, how much it starts at. should be equal to the percent over 100. Okay? Let's check to see if it's friendly. 10 to x, 20 to 100. Friendly? Okay, what can we do? Paikia? Multiply by 5. So if we take 20 times 5, we do get 100. So 10 times 5 should give us our x value. 10 times 5 is? 50. So the percent of change this time is 50% for beaker B. In other words, relative change means relative to what it started with. So it got 50%, there's 50% more liquid in this one versus the only one only added 20% more liquid relative to how much it started with. So in which beaker was the relative change of the amount of liquid greater? In beaker B. Okay, so beaker B had greater relative change. Write that out. Beaker B. Now don't just put beaker B. Let's answer the question. Beaker B had greater relative change. 50% is greater than 20%, right? So questions. Okay, let's go to the back and do one more then. Let's go do one with some coins. We have Sarah and Kira who are stacking coins. Both add 4 coins to their stacks. Can we answer this first question right away? What is the absolute change for each stack? Carly? 4 coins. How much are they going to change by? They're each going to change by 4 coins. Okay. Sarah's stack. What's important about that? What do we need to know about Sarah's stack? The original amount. We need to know how much she started with. There's 10 coins in her stack, to which 4 are going to get added. Kira's stack starts with 8, to which 4 are going to get added. Which one do you predict should have the greater relative change? Which one do you think is going to be affected more by adding 4 coins? Sarah's? Thumbs up for Sarah's. Sarah's stack is going to have greater relative change. Okay, Kira's? Kira seems to be more popular. Okay, well let's see what happens then. Okay, let's start with Sarah. What proportion can we set up for Sarah? Start me out. Harley, start the one side out for me. 10 coins over 4. Everybody agree with her?
Mm-hmm.
Starting amount over amount of change?
No.
No, I don't think so. Paikia? We need to switch that around. Yeah, we can't have the amount it changes by should be upstairs, or that's going to get thrown off on the other side. So how much did it change by, or in other words, the absolute change, and how much did she start with? She started with 10. What's the other ratio going to look like? Tyler?
8 coins, 4 coins over 8 coins.
The rest of Sarah's? I want the rest of Sarah's. Kaden, you want to help him out?
Maybe X coins over 100.
X coins?
Or
Flip your papers over if you have to. Flip your papers over. X what? X percent. We're trying to find what percent it's going to change by. So X percent over 100. Okay. Now let's check to see if this one is friendly. We need to get from 4 to X. So do we know what to do to get from 10 to 100? What?
Make it times 10.
multiplied by 10. 10 times 10 is 100. So we'll take 4 times 10, and that will give us our x value. So what's the relative change, the percent of change for Sarah's staff?
This is the easy part. Whatever's up there.
40%. Okay, so for all of us who thought maybe Sarah's relative change was going to be greater, that better be bigger than Kira's, huh? Okay, you find Kira's. Find Kira's percent of change.
See where you should.
Is this one friendly? It is, huh? You know what 8 times gives you 100? What times 8 gives you 100? Me either. Idea? Oh, she says, well then, if that doesn't work, try the vertical way. So in other words, we would have to go from 100 to x, can we go from 8 to 4? Oh, so this time instead of horizontal, we'll try vertical. So what do we have to do to get from 8 to 4? Multiply or divide? Divide, and divide by what? 2. So if we divide by 2 over there, we divide by 2 over here. 8 divided by 2 is 4. So 100 divided by 2 is x. So what does x equal? 50. Whose relative change is greater? Kira's, yeah. So all of you who said had a thumbs up for Kira. So can I get some reasoning why you thought, you smarties, why you thought Kira's would have greater relative change than Sarah's? You like her name better? Jenny? She had the smaller stack to start with, so it affected her stack more than it did Sarah's. Is that what happened on the front too? Was the one that had the smaller amount of liquid in it the one that was affected more? Yeah. So good job. So we're going to say for which stack of coins was the relative change greater? Kira's stack had greater relative change. And what's the other thing we think of when we hear the word relative change? What else are they talking about? What else are we going to think when we hear relative change? What have we been finding? Wait? Percent of change, yeah. Percent of change is the same thing as relative change. Just like it says on the front. Let's go back and back. Let's circle that on the front. Let's go back there. Anybody need this longer though before I do go back to that page? Got everything? Okay, let's go on the front and let's find where it says relative change is really percent of change. Right here. Circle that, star that, highlight it in your highlighter. So make sure that you understand that when they're asking you to find relative change, you're finding percent of change. When you're finding percent of change and they want to know what the relative change is, it's the same thing. Okay? Okay, so those are the 2 problems we're going to practice, and we'll get started on the homework now. Anybody have any questions though before we do? Okay, you guys go ahead and get some loose leaf out then.